All right, 10.7 is beyond Euclidean geometry. We're going to take a look at some vocabulary there. Wouldn't be a bad idea to get this in our notes or just on the handout. Vertex, similar to our triangle or polygon definition, is just a point where two edges meet. An edge is a line or a curve. That's key for you beyond the Euclidean geometry. It could be a line or a curve that starts and ends at a vertex. A graph is what we make when we use vertices and edges. And our last definition is even or odd vertex. That's going to be, every vertex is going to be one or the other. If an even number of edges meet at the vertex, it's an even vertex. And if it's an odd number, it's going to be an odd vertex. All right, we'll take a look at the picture on the bottom of the page. So right here, these are edges. Even if it's curves, it's still an edge. So this vertex here has 1, 2, 3 edges. So it would be an odd vertex, similar to this one here. 1, 2, 3, odd vertex. This one here has 2 edges meeting at it, even vertex. All right, our next definition, we've got some rules of traversability there. A graph is traversable if it can be traced without lifting the pencil from the paper and without tracing an edge more than once. And then you've got some rules listed there on our handout. A graph with all even vertices is traversable. You can start anywhere and end where you began. A graph with exactly 2 odd vertices is traversable if you start at either one of the odd vertices. And a graph with more than 2 vertices is not traversable. So again, traversable is, can you draw it or trace it without lifting your pencil and without tracing an edge more than once. All right, our first drawing has an odd vertex, and an even vertex. So from our rules, we can start at either one of the odd vertexes and draw our graph. We can make the whole graph without retracing anything, therefore it is traversable. Looking at our second graph, we have 1, 2, 3, 1, 2, 3, 1, 2, 3, 1, 2, 3, and 1, 2, 3, 4. So from our rules of traversability, if there's more than 2 odd vertices, it is not traversable. We can go ahead and try a few different times. Anywhere I start at A. Nope, I'm going to have to go over here in order to go through the whole thing. So try a couple times, but because of the rules of traversability, it has more than 2 odd vertices, it is not traversable. Let's look at a couple more examples. At vertex A, we've got 1, 2, 3, 4. So it's even. 1, 2, 3, 4. 1, 2, 3, 4. 1, 2, 3, 4. So in this graph, the entire thing, every one of them is even. So according to the rules of traversability, I can start anywhere. So I'll start at A, go all the way around. This is a pretty quick one. Then the next thing we need to do is we can list out our path. So my path, if you caught that, was A to D, that was this outside one, to C, to B, to A, and then I went back to D, to C, to B, to A. Started at A, ended at A. We traversed the entire path. All right, looking at the next one. This is even. B is odd, C is even, and D is odd. So I have exactly 2 odd vertices, which are traversable. So let's go ahead and give it a shot, as long as I start at one of the odd vertices. So starting at D, to A, to B, to D, to C, to B. So let's go ahead and list out our path. I went D, A, B, D, C, B. All right, so go ahead and try the rest of the drawings and see if they are traversable. Label the vertices, and then go ahead and try the homework.